Hello everyone and welcome to today's presentation. I'm excited to have you here. Today we'll be exploring the fascinating world of numbers, starting with the concept of the decimal number. On this first slide, you'll see the title, The Concept of Decimal Number. Over the next few slides, we'll cover what decimal numbers are, how they work, and why they are so important in everyday life. So let's get started and dive into understanding decimals. Let's take a quick look at the contents of today's lesson. We'll start with whole numbers, which are the most basic kind of numbers we use every day. Then, we'll move on to reading or writing decimals in words, which is an important skill for understanding and communicating numbers clearly. Next, we'll explore the decimal parts of numbers, understanding how they represent parts of a whole. We'll also learn how to represent decimals on a number line, giving us a visual way to see their size and position. Comparing and ordering decimals is another key concept, helping us understand which numbers are larger or smaller. We'll cover addition, subtraction, multiplication, and division of decimals, showing how to perform these operations accurately. Lastly, we'll look at how fractions and decimal numbers are related, emphasizing how they connect and convert into each other. All of these points build together to deepen our understanding of decimals and their role in math. Let's talk about whole numbers. The position of a digit within a number actually tells us its value. Think of it this way. The further to the left a digit is, the larger its place value. For example, in the number 345, the 3 is in the hundreds place, so it represents 300. Now, an important point is that each place to the left of the previous one is worth 10 times more. So, moving from ones to tens, and then to hundreds, each step increases the value by a factor of 10. Conversely, when we look to the right, each position has a value that is 1/10 of the position to its left. This system of place values is fundamental to understanding how numbers work. It connects directly to our overall goal of mastering number concepts, as recognizing these patterns helps us read, write, and compare numbers more effectively. Let's talk about decimal parts. When we work with whole numbers, the smallest unit we usually think about is the units place. But did you know we can go even smaller? To represent values smaller than 1, we use a decimal point, which looks like a dot, placed after the units. This decimal point is key because it signals that we're now talking about parts of a whole. Now imagine writing a number with a decimal point. Each digit to the right of that decimal point represents a fraction, where the denominator is always a power of 10. The very first position to the right of the decimal point is called the tenths place. So, if you see a digit in this position, it tells you how many tenths of a whole you have. This idea of extending the number line to include these smaller parts helps us understand and work with fractions more easily, especially when our measurements or values are less than 1. This concept is fundamental as we move forward in understanding decimal numbers and their role in our overall number system. Let's take a closer look at the decimal parts. Here, we're focusing on how the value of the positions to the left and right of the decimal point are represented. As you can see in the table, each position has a specific value that helps us understand and work with decimal numbers more accurately. The key idea is that the digit immediately to the left of the decimal point represents whole units, while the digits to the right indicate parts of those units, like tenths, hundredths, and so on. Recognizing these positions is fundamental because it allows us to interpret and perform calculations with decimal numbers precisely. This understanding ties into the overall theme of mastering number systems, which is essential for a variety of mathematical and real-world applications. A decimal fraction is a type of fraction where the denominator is a power of 10. That means it could be 10, 100, 1,000, or even larger powers like 10,000. The key idea here is that these fractions are based on the decimal system, making them very straightforward to work with, especially in everyday calculations. When we see a decimal fraction, it's essentially a way of expressing parts of a whole in a familiar, easy-to-understand format. This concept is fundamental because it connects fractions to our decimal number system, which is central to many of the calculations and measurements we use daily. So, understanding decimal fractions helps us see the relationship between fractions and decimals more clearly, which is a big step in mastering math concepts. All right, let's talk about how to read or write decimals in words. First, we start with step 1. Read the digits to the left of the decimal point as a whole number. So if you see a number like 3.45, you'd read the 3 as just 3. Next, step 2. Read the decimal point as the word and. This helps connect the whole number to the fractional part in a clear way. So in our example, after saying 3, we say, and to indicate the decimal is coming. Then, step 3. Read the digits to the right of the decimal point as a whole number, followed by the place value of the rightmost digit. For instance, if the digits are 45, you say 45, and then add the place value, which in this case is hundredths, because there are 2 digits after the decimal. This step is crucial because it tells us exactly what fractional part we're dealing with. The key idea here is that reading decimals in words involves these 3 steps to clearly communicate both the whole number and the fractional part. This method connects to the overall theme of understanding and expressing decimals accurately in everyday language. Now let's talk about how we can represent decimals on the number line. Essentially, decimals are rational numbers, which means they can be expressed as fractions. When we plot decimals on the number line, we divide each unit into smaller parts, like tenths, hundredths, or thousandths, to accurately locate them. By doing this, we're creating a visual way to understand where a decimal fits in relation to whole numbers. The key idea is that for any decimal, we find its corresponding point, what we call the image point, on the number line by dividing the segment into the appropriate parts. This approach helps us see the size of the decimal and how it compares to other numbers, reinforcing that decimals are just another way of representing numbers geometrically. Connecting this to our overall theme, it shows how understanding decimals visually can make grasping their value much more intuitive and concrete. All right, let's walk through how to compare and order decimals effectively. First, in step 1, we need to make sure each number has the same number of decimal places. We do this by adding zeros where necessary. This helps us compare the numbers more easily because they are aligned correctly. Next, in step 2, we ignore the decimal point entirely. Think of it as just looking at the numbers as whole numbers now. This simplifies the comparison process because we're only focusing on the value of the digits. Finally, in step 3, we determine which number is the greatest by comparing these whole numbers. The greatest number you find through this method will be the greatest decimal originally given. Remember, the key idea here is that by equalizing decimal places and temporarily ignoring the decimal point, we can confidently compare the sizes of decimal numbers. This method makes ordering decimals clear and straightforward. All right, let's walk through the steps for adding decimals. First, you want to arrange the numbers vertically, making sure the decimal points are perfectly lined up. This is crucial because it keeps the place values aligned correctly. Next, if any of the numbers have fewer decimal places, you should add zeros to make them all the same length. This ensures that each digit is in the correct position when you add. Then, you simply add the digits starting from the rightmost side, just like with whole numbers, working your way to the left. Remember to carry over if needed. And finally, when you're done, place the decimal point directly below the other decimal points in your numbers. This step keeps everything neat and accurate. Keeping these points in mind helps us master decimal addition, which is essential for accuracy in real-world calculations. Let's walk through the key steps for subtracting decimals. First, we start by writing the decimals vertically and making sure to line up the decimal points perfectly. This step is crucial because aligning the decimal points helps us keep track of the place values accurately. Next, if one number has fewer decimal places than the other, we add extra zeros to make them equal. This way, we're working with the same number of decimal places, which simplifies the subtraction process. Then, we move on to subtract the digits, beginning from the rightmost side, just like with whole numbers. Remember, if a digit on top is smaller than the digit below, we need to borrow from the next higher place value, just like in whole number subtraction. The most important part here is to keep the decimal point in mind. When we get to the bottom, we insert the decimal point directly below where the decimal points are in the numbers we're subtracting. By following these steps carefully, we can subtract decimals accurately and confidently. This method helps us stay organized and ensures that our answers are precise. All right, let's walk through the steps for multiplying decimals. First, ignore the decimal points and multiply the numbers as if they were whole numbers. This means you treat the decimals just like regular integers for now. Next, you need to figure out how many decimal places are in the original numbers. To do that, add together the number of decimal places from both decimals. This sum tells you how many decimal places your final answer should have. Finally, you insert the decimal point into your product so that it has the correct number of decimal places. Basically, you count from the right and place the decimal point accordingly. Remember, the key is to focus on the total number of decimal places, which ensures your answer stays accurate. This method keeps the process simple and helps connect our understanding of decimal multiplication to real-world applications. Now, let's talk about dividing a whole number by another whole number, especially when the quotient isn't a natural number. The key idea here is that we start by dividing as we normally would with whole numbers. But if the answer isn't a whole number, we need to introduce a decimal point. After placing the decimal point in the quotient, we also add zeros to the dividend as needed. This allows us to continue dividing smoothly and get an accurate decimal result. Remember, the main concept is to treat the division just like whole number division, but with the added step of inserting zeros and the decimal point to handle non-whole number answers. This method is essential for understanding how to work with decimal division in real-world calculations, and it ties into our overall theme of mastering division concepts. All right, let's walk through how to divide a decimal by a whole number. First, the key is to ignore the decimal point for a moment and treat the decimal as if it were a whole number. This simplifies the division process. Next, if necessary, we add zeros to the dividend. This helps us continue dividing smoothly, especially when the decimal part has fewer digits. Think of it as giving ourselves more digits to work with to get an accurate quotient. Finally, after we perform the division, we need to place the decimal point in the quotient. The crucial part here is ensuring that the decimal point in the answer has the correct number of decimal places, matching what we expect based on the original problem. This process is fundamental because it connects the idea of dividing decimals with the familiar process of dividing whole numbers, keeping the overall theme of understanding decimal operations clear and consistent. All right, let's walk through how to divide a decimal by another decimal step by step. First, in step 1, we want to make the divisor into a whole number. To do this, we move the decimal point to the right until the divisor is a whole number. It's important to count how many places we move the decimal point, because we'll need to move the decimal in the dividend the same number of places later on. Next, in step 2, we move the decimal point in the dividend the same number of places to the right. Sometimes, we might need to add zeros to the right of the dividend to fill in any gaps after moving the decimal point. This ensures the value stays the same and makes the division process easier. Finally, in step 3, we follow the usual steps for dividing a decimal by a whole number. Remember, the key here is adjusting both the divisor and the dividend so the divisor becomes a whole number, which simplifies the division process. This method keeps our calculations accurate and consistent, connecting to the overall theme of mastering decimal operations efficiently. All right, let's talk about dividing a whole number by a decimal. The first step is to make the divisor into a whole number. To do this, we move the decimal point to the right until the divisor is a whole number. It's important to count exactly how many places we move the decimal point, because we'll need to do the same later. Next, we perform the division as usual. If necessary, we add zeros to the right of the dividend to make the division easier and to ensure accuracy. Finally, we adjust the decimal point in the quotient. We move it to the right the same number of places we moved the decimal in the divisor. This keeps our answer accurate and consistent with the original problem. Remember, the key here is understanding how shifting the decimal point in the divisor affects the division, and then applying that same shift to the quotient. This technique helps us handle divisions involving decimals smoothly and correctly. Now, let's talk about what happens when we convert fractions into decimal numbers, specifically focusing on terminating decimals. When we take the numerator of a fraction and divide it by the denominator, we get a decimal. This is pretty straightforward, right? But what's really important to understand is when this decimal stops. That is, when it has a finite number of decimal places. We call such decimals terminating decimals. Essentially, these decimals come from fractions where the division results in a clear, ending decimal expansion. Recognizing these is key, because it helps us see the direct connection between fractions and decimals, which is central to understanding how different representations of numbers relate to each other in math. All right, let's walk through how to convert a terminating decimal into a fraction. The process is straightforward and follows a few simple steps. First, we ignore the decimal point and just write down the number as a whole. This helps us focus on the digits themselves without the decimal distraction. Next, we draw a fraction bar, which visually separates the numerator and denominator. Then, for the denominator, we write a power of 10. The key here is to match the number of zeros to the number of decimal digits in our original number. So if there are 2 decimal places, we write 100. If 3, then 1,000, and so on. Finally, we simplify the fraction if possible, reducing it to its lowest terms. This step ensures our answer is as simple as it can be. Remember, these steps are part of the bigger picture of understanding how decimals and fractions relate, helping us interpret and manipulate numbers more effectively. All right, let's talk about repeating decimals. When we have a decimal number and its fractional part keeps repeating endlessly, we call that a repeating decimal. Essentially, if the digits after the decimal point go on forever in a pattern, that's what we mean by repeating. This concept is important because it helps us understand how certain fractions translate into decimal form. Recognizing repeating decimals also connects to the broader idea of how fractions and decimals relate. It's a fascinating part of number theory that shows the beautiful patterns within mathematics. Now, let's walk through how to convert a repeating decimal into a fraction step by step. First, in step 1, we write the number without the decimal point. This means we take the entire number and just write it as a whole number, ignoring the decimal for now. Next, in step 2, we subtract the non-repeating part of the decimal from that number. This helps us isolate the repeating part and set up our fraction properly. Moving on to step 3, we write this difference as the numerator of our fraction. It's the top part of our fraction that represents the difference we calculated. In step 4, we focus on the denominator. Here, we write a number consisting of 9s and 0s. The number of 9s matches the number of repeating digits in the decimal, and the 0s match the number of non-repeating digits. This step is key because it captures the repeating pattern mathematically. Finally, in step 5, we simplify the fraction if possible. Simplifying helps us get the fraction into its most reduced form, making it easier to understand and use. Overall, these steps tie back to the presentation's theme of understanding how decimal patterns translate into fractions, giving us a clear, methodical way to convert repeating decimals into exact fractions.